So, due to some interest in mathematics, some of them love it, some of them don't, I decided to make a new lectures, and today the well-known problem, it is a birthday paradox from the statistics, and from those of you who don't know, the problem is about, we have a group of, say, n students, n is number of students, and we would like to know if two or more of them have birthday on the same day. So we will say k is the number of repeated birthdays. So if the k is 2, then we're searching for 2 to have birthday on the same day, and if it's 3, then 3 people, and so on. You get the point. And d, we will say that is the number of days in the year, and we will choose 365 to include also the ones who have birthday on February 29. And here is the table which we would like to fulfill. Here is n, and we will choose 23 people. It will be clear why 23 later. 50 and 70 students in the group. And we would like to know if 2 of them have birthdays, or even 3 of them, to extend the problem, even 3 of them have birthday on the same day. And you will be able to calculate even for more, 4 or 5, or as many as you wish. And the problem we will solve in 2 approaches. First approach is standard, and second one is approximation. So now that it will go faster, I will fulfill, and we will just go through more quickly. So let's get started. Well, first approach, here it is. We are searching for probability of big X, which is actually 1 minus probability of X prime, where 1 is 100%, and this probability is actually the one that no 2 or more people have birthdays on the same day. And this probability consists of a quotient of, say, A and B, where A is total number of birthdays without repetition, and B is total space of outcomes. This means that A is D factorial divided by D minus N factorial, where D, as we said, is the number of days in the year, and N is the number of students. And inserting these 2 values in the formula above, we get this result for probability, you see here, and this is valid only if 2 students have birthday on the same day. And the values I have calculated are, for 23 people, we get 50.7% chance that 2 share the birthday on the same day. Then for 50 people, this number is already 97%. And for 70 people, we get 99.9%. So one would thought that we need half of this number for 50% chance, but it turns out that this number is only 23. And now we are curious and would like to know also if 3 people share birthday, and we will do it right now. I will stop this, and we proceed. Now, for the second approach, exact formula is quite complicated, and that's why I decided to use approximation, and we will use Poisson distribution approximation, while it turns out that it is quite a good approximation for this problem. And Poisson approximation is defined, probability of X prime is defined as lambda, that's Greek letter, to the power of n times e, exponential function, to the power of minus lambda divided by n factorial, where n is number of occurrences, and it can be also 0, which it is in our case. And lambda is expected value of x, which is also the same as variance of x for Poisson distribution. And this lambda consists of, again, quotient of 2 terms A and B, where A is number of pairs or triples, or 4 if you would like to know for 4 people, and as many as you will, you just change this number. And B is the chance that A is a success. This number is number of days in the year to the power of k minus 1. Inserting these two values in the formula for probability, again we need to subtract from 1 minus exponential function. This is the formula you see you have two variables, n and k, so you can do for as many as you like again. And it turns out that values are 1.3% only for 23 people, and then 13.7% for 50 people, and 33.7% for 70 people. So that is why, if you were wondering why you know, I'm sure that most of you know at least 2 people that share the birthday on the same day, or even 3 people now know why this is. So, for me, kind of interesting statistics. I hope you like it, and I hope you like the program. Thanks to my team, and thank you all for listening.